Welcome to Brain Vision.
Okay, so let's take a look here. We have two ropes of equal length, and they are stretched the same way. So our first step for any given problem would be to sketch and translate as dictated in the problem-solving strategy. So we have two ropes. These ropes have the same length, we'll call L, and it also indicates that they are stretched the same way. This means that our tension force is the same. So force tension 1 is equal to the force tension 2. And so we are provided with the fact that if you were to have a wave pulse on either of these, on these two strings, that V1 compared to V2 would be 1.4 times V2. That's going to become important later. Now our goal is to calculate the ratio of the masses of these two strings. And so given that we know what the relationship between the tension, the length, and the mass is, our next step would be to represent mathematically. There's no real diagrams you can do for this, so we're going to go straight to representing it mathematically. And for this problem, if we're talking about waves on a string, we're talking about the equation V is equal to the square root of the tension over mu, where mu is the linear mass density of the string, where linear mass density is effectively the mass over the length. And so in an AP problem, when you're asked to find a ratio like this, typically what you do is you find the equation that you're looking for that has all the values for each object, in this case the strings, and you then you sort of combine them in the way that will give you the combination that you need. So since we're looking for a ratio here, we'll divide, and for ratios you'll do that mostly. We're going to divide the two equations so that we can then simplify it down and get the result we're looking for, which is this m1 over m2. So I'll write an equation for both of the strings, and then sort of we'll divide them. So V1 is equal to the square root of the force tension divided by M1L over L. And you'll notice I'm not putting in FT1 and L1. That is because we already know that the tension is the same for both, and the L is the same for both. So I'm only indicating the difference in M and V, since those are the only things that are different between the two strings. So V2 is equal to the square root of the tension divided by M2 over L. And so what we're going to do is we're going to divide these two equations. So since we're dividing by a fraction, I'm going to multiply by the reciprocal to just sort of simplify the algebra a little bit. And we end up with V1 over V2 is equal to square root of the tension divided by M1 over L times the square root of the M2 over L, since we're multiplying by the reciprocal, divided by the tension. And so as we're multiplying these together, you can see that we're starting to simplify already. Our tensions cancel out. And so we're left with V1 over V2 is equal to the square root. I'm going to simplify a little bit here, L over M1, since M1 over L was in the denominator, times the square root of M2 over L. And once again, we can simplify a little bit more, get rid of the L's, and what we're left with, I'm going to take this over here, what we're left with is V1 over V2 is equal to the square root of M2 over M1. Now, keep in mind also that we already know the relationship between V1 and V2, so we can actually rewrite that, since we know V1 is 1.4 times V2, and we can rewrite that as 1.4 V2 over V2 is equal to the square root of M2 over M1. And again, these two cancel out, so we're left with that 1.4 is equal to square root of M2 over M1. But we want M1 over M2, and we want to have it not be square rooted. So we're going to square both sides, and then we are going to invert them to get the right ratio. So we've got M1 over M2, I mentioned. So again, we squared both sides. So we have the square of 1 over 1.4, since we also inverted it. And when you do that out, you get 0.51. So 0.51 is our ratio of M1 to M2. Thanks.